Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. This is part 4, the chapter is resonance structures of some organic compounds. In part 4, I will explain chlorobenzene, amine and benzene diazonium chloride. Let us start chlorobenzene. In chlorobenzene, you can see chlorine is attached to benzene ring, and here how many pair of electrons, that is 3 pair of electrons. And here you can see the out of 3 pair of electron are delocalized to the adjacent sigma covalent bond. That means this is the pair of electron delocalized to the adjacent bond, and automatically here it gives pressure. That means it becomes to unstable, and the the pi bond electron that is delocalized to the adjacent carbon atoms. Now what happened here, this since it delocalized to this carbon, that is why it acquires a pair of electron with a negative charge, and this since the pair of electron localized to here, that is why it acquires a double bond having chlorine positive charge. And how many pair of electron here? 2 pair of electrons, and here 3 pair of electrons. Since 1 pair of electrons that is delocalized to this bond, that is why it acquires a double bond having chlorine positive charge. And now since it is a pair of electron with negative sign, so this pair of electron delocalize to the adjacent bond, and here and again this pi bond, that pair of electron that is having pi bond, that is delocalized to this carbon adjacent carbon atom. So in next case what happened, it acquires a pair of electron having negative charge, and this pair of electron having negative charge and come to here and becomes a double bond. See here there is no bond, but here there is a double bond. Here since a pair of electron with negative sign, that is why this pair of electron delocalized to the adjacent bond, and this pair of electron where pi bond is there, and here the pair of electrons delocalized to the adjacent carbon atom, and here same as chlorine positive sign, 2 pair of electron having double bond. Now you can observe here since a pair of electron is there and having negative sign, so it is delocalized to the just adjacent bond, and this pi bond electron that is delocalized to this adjacent carbon. That is why this part occupies a pair of electron having negative sign, and here it changes to double bond, that is pi electrons here and pi electron, that is why pi bond is formed. And after that also you can find, since here negative charge with pair of electron is there, and that is that pair of electron delocalized to this adjacent bond. And what happened here, in next case you can observe, since it delocalized to this, so it forms a pi bond. And here what happened, since there is a double bond and having chlorine positive sign and also 2 pair of electrons present, that is why the delocalization of electron takes place to chlorine, and after that it changes to the plus sign is not there, and it changes to 3 pair of electrons and having the double bond changes to single bond. And what is the first structure and last structure? What is the difference? Nothing, only the Keiko structure, the alternate double bond, that is changed. It is that is happening in the last structure. So these are the resonance structures 1, 2, 3, and the 3 are main resonance structures where chlorine occupies a positive charge having 2 pair of electron and double bond, and you can find here ortho both two are ortho, and here that is para, all are occupying negative sign. So chlorobenzene is ortho para directing. That you can understand from this resonance structure how it is ortho para directing. Now you can find here ortho position, para position, and here ortho position, all are occupying negative sign. That is why it is ortho para directing. Then come to amine. You know amine also nitrogen having one lone pair of electron, and the formula benzene ring with NH2 group, and that is called amine. And since it is a lone pair of electron present on the nitrogen atom, that is why these electrons, pair of electrons that can be delocalized to this bond, this adjacent bond which is attached to benzene, and automatically this here the double bond, and now it will become unstable, and here that moves to the ortho position, that is ortho carbon atom, where it occupies a negative charge having pair of electrons. Now since the pair of electron moves to this bond, that is why it occupies a double bond, and nitrogen occupies a positive charge. Now you see in this case here what happens, a pair of electrons with negative charge is there, that is why this is delocalized to the adjacent bond, and here since pi electrons are there, one pi bond is there, this electron delocalized to this carbon is para position. Now you can find after that what happened, here it occupies negative sign having two electrons, and automatically what happened to this pi electrons, where pi bond is formed, here the pair of electron moves to this carbon, that is also at ortho position carbon. That is why you can find in next structure here, that is pair of electron having negative sign, and here this occupies a double bond. Since a pair of electron with negative sign is present in ortho position, that is why this pair of electrons delocalize to the adjacent bond, and here this double bond become unstable, and here also the pair of electron delocalize to the nitrogen, where it contains now positive charge. So what happens here, next structure, it becomes a double bond, and it becomes as it is there in the first case. So here it becomes to no positive charge, it contains a lone pair of electrons on nitrogen and hydrogen on both sides. One side is benzene. This is the that is capable form of the structure, and you can find these three are resonance structure of amine, where ortho and para position they occupy negative charge having a pair of electrons. That is why you can find amine is ortho para directing. See here again, amine is ortho para directing because ortho position that contains a pair of electron having negative charge, similarly para, and this side ortho also same case, so they are occupying negative charge having pair of electrons. So it is very easy when you understand this how the electrons moves from carbon atom to the bond, and how the pi bond electron moves to the carbon atom at ortho and para, then it is clear. Then come to benzene diazonium chloride. What is the formula? C6H5N2 plus Cl minus. That means benzene ring with N plus and triple bond N having a lone pair of electron. That means you can observe what happens here, N contain positive charge and there is a triple bond, and now what happens, the out of triple bond each one is our covalent bond, and here what happened, one that electron moves, the electron delocalize to the near what is present, the nitrogen present, to delocalize to this nitrogen which contains a pair of electron. And now since it delocalized to this nitrogen, what happens here, since it contains a double bond, so the pair of electrons from this pi bond moves or delocalized to this bond, this adjacent bond which is attached to N2 plus and benzene. So here pi electron moves to the this bond which is attached to N2 plus. So next case, what happens here? It becomes to double bond because the electron moves to the adjacent bond. That is why it acquires, that is double bond, and as it is N plus, and since one bond electron delocalized to this, that is why there is another pair of electron and having negative sign. And so I told here benzene diazonium chloride, where benzene diazonium ion contains positive charge, and here two nitrogen atoms present and one containing a lone pair of electron, and here three bonds are there, that is triple bond. In first case the ortho position occupies positive charge, in second case the first case it occupies positive charge, in second case the pi electron moves to here, that is why para position occupies positive charge. And this pi electron delocalized to this adjacent bond, that is why the positive charge cancel. And here in next case what happened, here it occupies a double bond, and this ortho position occupies a positive charge, whereas the nitrogen as it is contain one positive charge, other contain negative charge, having two bonds and two lone pair of electrons. Now since you can observe, first case it is ortho, second case para, third case resonance, that is ortho also containing that positive charge. In last case what happened, the double bond electron here pi electron moves to this bond, and that is why it occupies here double bond, and whereas positive sign is not there. And now since it contains two lone pair of electron having negative sign on this nitrogen, so it delocalized to this bond. That means in last case what happened, and there are three bonds, that is triple bond between one nitrogen and other, and first nitrogen containing positive charge and next nitrogen containing a lone pair of electron. Now you can observe the first case and last case only alternative double bonds are different, that one is Kekulé structure of other. Now here this ortho and para, they are occupying positive charge. So benzene diazonium chloride, where the formula is C6H5N2 plus Cl minus. If only you want to see benzene diazonium ion resonance, you can find ortho and para position, they are occupying positive charge. I hope it is clear. Chlorobenzene, which is ortho para directing, amine also ortho para directing. Why? Because in resonance structure you can find ortho and para position, they are occupying negative charge having one pair of electron. In amine also in same case, ortho and para position, they are occupying the negative charge with pair of electron. Whereas benzene diazonium ion, here ortho and para position, they are occupying positive charge. So I hope the resonance structure of chlorobenzene, amine and benzene diazonium ion is clear to you, and I hope you will like this video and like and share and subscribe my channel BL Das Short and Sweet in Chemistry. Thank you all. Thanks.